Hey, welcome back to your favorite trigonometry class. Going to look at trig identities today and using some algebra to simplify as well as establishing identities. So what is an identity? That's just saying when two functions are identically equal. So we'll actually use our trig identities to prove some of these things. Okay. Here's our quotient identities. If you remember, tangent, sine over cosine, cotangent, cosine over sine are reciprocal identities. Our Pythagorean identities, I remember this one's what I always refer to as the money formula. It seems to always pop up. If you divide everything by cosine squared, you get that one. If you take the money formula and divide everything by sine squared, then you can end up with that one there. Okay, even odd identities. If you remember, the sign is odd, right? Remember, odd means f of negative x is negative f of x. So tangent and sine are odd, and they're reciprocals there. Whereas the cosine is an even function. So if you remember, even functions mean f of negative x equals f of x, kind of like y equals x squared. Right? Odd is kind of like y equals x cubed. Alright, so we've got some basic algebraic techniques. So what we're going to do to establish these identities, we're going to rewrite them in terms of sine and cosine only. We can multiply a numerator and divide our denominator by a ratio by a well-chosen one, or multiply by a conjugate. Okay. We're also going to write sums of trig ratios as a single ratio, and we're going to use factoring. So all of those approaches. So let's do this first one here, A. It says simplify tangent over secant by rewriting in terms of the sine and the cosine. So let's tangent over secant. So we're like, well, by our quotient identities, the tangent sine over cosine, and then the secant we know as 1 over cosine, reciprocal identities. And now we've just got this complex fraction, so we go ahead and we multiply by the reciprocal of the denominator there, right? Like keep change flip, if you will. So we're just going to multiply by 1, right? We multiply top and bottom by cosine. Cosine over 1, or the reciprocal of that 1 over cosine there. And you notice cosines cancel, so you're just left with the sine of theta. That's it. We clean that up. B. We're going to show that the sine over 1 minus cosine is equal to 1 plus cosine over sine. So what I'm going to do, I'm going to work with the left-hand side. Typically, you want to pick the more complex side, but you can pick either side to work from. I'm going to work with this left-hand side. And I'm going to multiply by the conjugate of 1 minus cosine theta. So the conjugate of 1 minus cosine theta, that just changes the sign between the two terms. So it is 1 plus cosine theta. Well, I can't all of a sudden do that. That means I got to do it to the top too. So 1 plus cosine theta. So now this becomes, I'm just working with this left-hand side. I got sine theta, 1 plus cosine theta. On the denominator, I'm going to go ahead and FOIL that. So my denominator becomes 1 minus cosine plus cosine minus cosine squared theta. And then at this point, notice I have 1 minus cosine squared theta. So I'm going to make a substitution right here. Substitution. Remember, sine squared plus cosine squared is 1. So what is 1 minus cosine squared? If I subtract cosine squared both sides, sine squared is the exact same thing as 1 minus cosine squared theta, right, from our Pythagorean identity. So I'm going to go ahead and I'm going to substitute that. So 1 minus cosine squared is sine squared, right? So I'm going to substitute that in right there. So my denominator becomes sine squared theta. Then my numerator is still sine sine theta times 1 plus cosine theta. And notice, one of these sines cancels with one of those, so you just have sine theta on the bottom. So this is 1 plus, I kind of ran out of room here, 1 plus cosine theta all over sine theta. That's what we wanted to show. We wanted to show it was equal to the right-hand side. 1 plus cosine theta over sine theta. Check mark. See it? Alright, let's do C. I gotta clean this up a little bit before I do C and D. Alright, simplify. We got cosine squared theta minus 1 over tangent of theta, cosine theta plus tangent of theta. So here what I'm going to do is I'm going to factor the numerator. That's like x squared minus y squared is x minus y, x plus y. So factor the numerator, cosine theta minus 1, cosine theta plus 1. The reason I'm going to do that is because I notice in the denominator both of these have a tangent. So I'm going to factor out a tangent and I'd be left with cosine theta plus 1. See how that's going to cancel for you? So I got cosine theta minus 1 over tangent theta. Simplified it real nice just by factoring there. D. You know what, let me give myself some more room again. Alright, we have 1 plus sine of u over sine u plus cotangent u minus cosine u whole over cosine u. And it says simplify by rewriting the expression as a single ratio. Well, you guys know if you're adding like 1/2 and 1/3 together, you got to get a common denominator, right? So we're going to do that same thing here. We're going to get a common denominator. The right-hand side's denominator is cosine u. Left-hand side is sine u. So I'm going to give this one a cosine u, which means I got to multiply the top also by cosine u. So now the denominator here is cosine u sine u on the left. On the right, it's only cosine, so I need to give it a sign. Now, sine u over sine u. So I'm just multiplying this by 1. But now they have a common denominator, right? They both have sine u cosine u. So I can add them up. So I have cosine u times 1 plus sine u plus, over here I got sine u times cotangent. And I'm going to switch that to cosine over sine. That's cosine u. Okay. And distribute this now. So now I have cosine u plus cosine u sine u, or sine u cosine u, cosine u sine u, plus, notice when I distribute this one right here, the signs will cancel because I have a sign on the top, sign on the bottom right there. So I'm just left with cosine u there. Then I distribute it to here, so I got minus cosine u sine u. And this is all over sine u cosine u. Notice cosine u sine u minus cosine u sine u gone. So I got cosine u plus cosine u is 2 of those cosine u's over sine u cosine u. Now everything you notice is there's no more addition here, so we can just cancel it, right? Because this is being multiplied right there, sine u times cosine u on the bottom. So I got 2 over sine u. Or you could also write that, you know, that's the same as 2 cosecant of u, isn't it? Either of those would be fine. Right? All right, now let's establish the identity. So again, we want to pick our, or here, you know, you can work with your left or right hand side, but you want to pick your more complex side. So I'm going to use my left hand side and show that it's equal to my right hand side, the secant of theta. So I have cosecant tangent, and the first thing I'm going to do is I'm going to take the cosecant I'm going to make it in terms of sine and cosine. So this is 1 over sine theta times the tangent, which is sine over cosine. And I'm only working with this left-hand side. I'm trying to show it's equal to secant. Notice those cancel. This one's real easy. I've just got 1 over cosine, which we know is the secant. So secant theta equals secant theta. Done. Just establish that identity. Let's do another one here. This is using your even-odd properties. So notice you have sine squared negative theta plus cosine squared negative theta. In fact, let me write that another way. This is the same as sine of negative theta quantity squared. That's the same thing, right? That's cosine of negative theta. There's 2 of those. You multiply equals 1. So if you remember, sine is odd. I'm sorry. Sine of negative theta equals negative sine of theta, and then cosine is even. So I'm going to use those properties, the fact that sine's odd and cosine's even. So I'm going to replace sine of negative theta with negative sine theta. So this is negative sine theta squared, right? So negative sine times another negative sine is a positive sine squared theta, okay? Now cosine of negative theta becomes cosine theta. So this is just cosine theta squared, or cosine squared theta, right? Put it in the proper notation now. And we know sine squared plus cosine squared is 1. 1 equals 1. There you go. Just establish the identity. So again, we worked with the left-hand side, whittled it down until we showed that it's equal to that right-hand side. You always want to work with your more complex side. Here's another one with even odd identities on this one. So we have sine squared negative theta. So I'm going to replace that with negative sine of theta. And there's 2 of those. Minus, I have cosine of negative theta quantity squared. So that's just cosine theta squared. On the bottom, sine of negative theta is negative sine theta, minus cosine of negative theta is just cosine theta, right? So we've got sine squared theta minus cosine squared theta on the top. On the bottom, I have negative sine minus cosine. What I'm going to do, I'm going to factor out that negative there. So I have sine plus cosine on that. Okay. And now I'm going to factor the numerator. So I know that's difference of squares, sine minus cosine, sine plus cosine. This is all over notice those cancel. And then what I'm also going to do is I'm going to take that negative up top. Okay, so I got negative, I've got sine theta minus cosine theta. Those factors canceled right there. So I have sine theta, negative sine theta plus cosine theta. In other words, cosine theta minus sine theta. That's what we're trying to get to. Remember, I'm always kind of looking at that right-hand side, trying to get to that point, right? We just got to that point, working at that left-hand side there. All right, example, excuse me, example 5 here. 1 plus the tangent over 1 plus the cotangent. Again, let's get this in terms of sine and cosine. So I have sine u over cosine u over 1 plus, and this one's cosine over sine. Now what I'm going to do is since I have this 1 plus, right, I want to get that numerator as just one fraction. I want to get the denominator as one fraction. So I can simplify it into one ratio. I have a ratio on the top divided by a ratio on the bottom, so I have a complex fraction that I can then simplify, right? It's just like your algebraic approaches. It's just that now we have some trig functions involved here, right? So this is 1 over 1. Give it a common denominator. I'm going to give it cosine u, cosine u. This is 1 over 1. Here I want it to have sine u, sine u. So now my numerator becomes 1 times cosine u is just cosine u plus sine u. This is all over my common denominator. Whoops. Common denominator cosine u. All divided by, my goodness, all divided by, let me do the bottom here in like blue or something, sine u plus cosine u all over my common denominator of sine u. Right, so now I got quotient divided by another quotient, right? So I got this complex fraction. So we're going to keep change flip. We're going to multiply by the reciprocal there of that denominator. So let's go ahead and multiply by reciprocal. So sine u over sine u plus cosine u. That means I got to do it. And notice cosine u plus sine u, this and this, same thing, right? Isn't 2 plus 3 same as 3 plus 2? Sure. So I'm just left with sine u over cosine u. Sine u over cosine u, which is tangent of u. There we go. That's what I was trying to show, tangent of u. It whittles down. We established the identity there. Awesome. All right, here we've got summation. I'm going to again work with my left-hand side on this thing, and I'm going to again get a common denominator on this thing. So I'm going to notice this has sine of theta, but this does not. So I'm going to give this sine theta. Over here, I'm going to give this side 1 plus cosine theta. Okay, so this becomes sine squared theta plus 1 plus cosine theta times another 1 plus cosine theta. So I got two of those all over. Now I've got this common denominator, sine theta 1 plus cosine theta. And I'm trying to show that it's equal to 2 cosecant of theta, right? Now what I'm going to do is I'm going to expand this. So 1 plus cosine times another 1 plus cosine, if I was to FOIL that, is 1 plus 2 cosine theta plus cosine squared theta. This is all over sine theta times 1 plus cosine theta. Now notice this. There's my money formula. Sine squared plus cosine squared. What does that give you? That's 1. That's 1. Right? And then I've got the plus 1 plus 2 cosine. Plus 1 plus 2 cosine theta. This is all over our denominator here. Sine theta 1 plus cosine theta. So notice I got 2 plus 2 cosine theta. 2 plus 2 cosine theta over sine times 1 plus cosine. I'm going to factor 2 out of both of those so that I have 1 plus cosine, because I see, hey, if I factor a 2 out, I have 1 plus cosine. I got the same terms right there, so that'll cancel and it'll leave me with 2 over sine of theta. In other words, 2 times 1 over sine. In other words, 2 cosecant of theta. Okay? Just established that identity. Beautiful. Let's keep going here. Tangent v plus cotangent of v. Let's get this sucker in terms of sine and cosine. So I got sine v over cosine v plus cosine v over sine v. All over secant's 1 over cosine. Cosecant's 1 over sine. See that plus up there in the numerator, so we got to get a common denominator. So give this one a cosine. Give this one a sine. And then notice the on the bottom we've just got that it's being multiplied, right? So our denominator is just 1 over sine v cosine v. Alright, so the numerator we got sine squared plus cosine squared, which we know sine squared v plus cosine squared v, that's 1 on the top, over this common denominator, sine v cosine v. So this is 1 over sine v cosine v all over 1 over sine v cosine v. So I got, it's like 3 over 3, right? What's 3 over 3? Well, that's 1. Or if you want to go ahead and multiply by the reciprocal of the denominator, you can do that as well. But hey, there we go. Established another identity. All right, how about this one here? 1 minus sine over cosine. So the trick on this one is, and notice I'm trying to get to the right-hand side again, but the trick here is use the conjugate. Okay, there's not a whole lot else. There might be other approaches to do it, but the conjugate's going to work real nicely on this one. 1 plus sine theta, which means we got to do it to the bottom. So we got 1 plus sine theta 1 minus sine theta all over 1 plus sine theta times a cosine theta. And then I'm going to go ahead and FOIL this. So I got 1 minus sine plus sine, those are gone, minus sine squared. So 1 minus sine squared theta on the top. I'm going to put that cosine theta in front there. Now we know 1 minus sine squared, remember, sine squared plus cosine squared is 1. What is 1 minus sine squared? Cosine squared is the exact same thing as 1 minus sine squared theta according to our money formula, our Pythagorean identity. So 1 minus sine squared is what? Cosine squared. So I'm going to make that substitution right there for this 1 minus sine squared. So now I've got cosine squared theta by substitution over cosine theta times 1 plus sine theta. And notice one of those in the numerator cancel with that. So we're just left with 1 cosine theta. So I've got cosine theta over that 1 plus sine theta. Hey, there it is. We just established that identity as well. So there's our guidelines. All right, use a more complicated expression, rewrite sum or differences as a single quotient, rewrite in terms of sine and cosine only. Keep the goal in mind. What are you trying to get to? And you're just kind of playing with these. I think that's the best way to explain it, is you're playing with these algebraically. Thank you so much for listening. We'll see you guys next time.